Hello everyone. Today we'll be looking at a chemical engineering gate question number 42 from gate 2018. A binary distillation column is designed by McCabe-Thiele method to get a distillate mole fraction of 0.9. The enriching section operating line has an intercept with the y-axis at 0.3 mole fraction. The ratio of liquid to vapor molar flow rate in the enriching section is dash rounded off to third decimal place. So this is a question from distillation part from mass transfer operations, and the reference NPTEL lecture can be found in lecture 3 week 9 number of trays by McCabe and Thiele for distillation, mass transfer operations 1 by Professor B. Mandal, Department of Chemical Engineering, IIT Guwahati. So here they have given some data. XD is equal to 0.9, which is the mole fraction of the more volatile component in the distillate. They have also given us the data for intercept. So let's draw our x and y axis. We have the 45-degree line and we can draw our equilibrium curve. So the operating line for enriching section, so the intercept with the 45-degree line is at xd, xd, and the intercept of this operating line for the enriching section is 0.3. So the general equation for the enriching section, we can write that as y is equal to r by r plus 1 into x plus xd by r plus 1. So this means that the enriching section line, the intercept of this enriching section line is the constant xd by r plus 1, because this line is in the form of mx plus c, where m is the slope and the slope of this line is r by r plus 1, and c, the constant, is the intercept, which is xd by r plus 1. So this 0.3 is xd by r plus 1, and the slope of the enriching section line is r by r plus 1. This can also be written as L by V, because we have another form of this general equation, which is y is equal to L by V into x plus B by V into xd. So basically the liquid to vapor molar flow rate in the enriching section is nothing but the slope of the enriching section operating line, which we can also write it as r by r plus 1. So r is the reflex ratio here. So let us write down the data. Xd by r plus 1, they have given us 0.3. So just substitute the value for xd. We'll have 0.9 by r plus 1 is equal to 0.3. And we can solve this equation to find the value of r, which is the reflex ratio. So we can get r is equal to 2. Now the L by V, which is nothing but the liquid to vapor molar flow rate in the enriching section, we can write it as r by r plus 1, which is the slope of the operating line of the enriching section. So substitute the value for r, we'll get L by V is equal to 2 by 2 plus 1, which is 2 by 3, which is 0.667. Thank you.